Good morning, children. Meeting after the long time in the sense since 2 to 3 days, and I think you enjoyed Sankranti also. So the main thing is again we came back to the same position, that is online classes. So I think 1 year back, 3, 6, 7 months back, we used to do the same thing, online classes only. So today also we're going with the same thing, and the main thing is here we are starting with the arithmetic progressions here. Already for some class, maybe A section or B section, some portions has been completed more and some class it has been less. So today I try to equate it for both the classes so that you can move forward with the same portions, with the same thing. So I think we are starting with the sequences. So I told you what you mean by sequence also. What is sequence in arithmetic progression? I think I already given the definition of sequence. If not, we can write the definition of the sequence also. An orderly arrangement of numbers according to a certain rule. Is called a sequence. So I think this definition I already given. See, one thing what he's saying is an orderly arrangement of numbers according to certain rule. The word certain rule is very important here. I told you already. What do you mean by certain rule? It should have certain rule. It should follow some certain rule in sequence. If it follows the certain rule, that too according to a certain rule, and arrangements should be follow certain rule. The numbers should follow certain rule. Then we call it as a sequence. So let us see for the examples. And what do you call the numbers in a sequence? Each number in the sequence is called each number in the sequence is called a term of the sequence. Term of the sequence. Let us take some example. Here is given example. For example, in the sequence you can take any sequences here. You can take 2, 4, 6, 8, 10. These are the sequences. Why you call it as a sequence? Because they are following certain rule. What rule they are following here? Some rules are there. They are the tables of 2. No, it is not like this. For example, if you add 2 for 2, you will get 4. And if you add 2 for 4, you will get 6. And if you add 2 for 6, you will get 8, and so on. So they are following some certain rule. So again he is saying each number in the sequence is called a term of the sequence. So when you use the word term, so term of the sequence in the sense, for example, we have, which is the first term here? First term is 2, this is first term, and we have second term is 4, so we have second term here, and third term is 6. So these are called the terms of the sequence. So each number which are present in the sequence is called the terms of the sequence. So that is, the first term is 2, second term is 4, and the third term is 6. This is what you call the terms of the sequence. And how to represent these terms? There are two types of numbers where you can represent the sequence. For example, if you want to represent the sequence, the first term is 2 here. In the first term is 2, what do you call? You can say T1 equals to 2, why? Because it is first term. Or if you want, you can write A1 equals to 2 also. You can represent them in two terms. And T2 is the second term. It may be 4 or A2 equals to 4. And we have the third term. Which is the third term here? 6 is the third term. You can call T3 equals to 6, or it may be represented as A3 equals to 6. So each term is represented by each capital letter. If we can represent it by the T1, T2, T3, it is very easy to remember. T represents the term here. T1 equals to 2, T2 equals to 4, and T3 equals to 6. Or if you represent, you can represent in the form of A1 also. A1 equals to 2, A2 equals to 4, A3 equals to 6. These are called the terms of the numbers, or you can call the terms which are present in the sequence. So here each term is called numbers in the sequence which are present here. So first term is 2, second term is 4, third term is 6, or it may be represented as A1, A2 or A3 equals to 6 here. So here, which will be the last term then? For example, if I take the sequences here, T1, T2, if I take T3, T4, so which will be the last term? Generally we use the word nth term. Tn will be the last term. Or if you want, you can go like this also. A1, A2, A3, A4, and the last is nth term. N may be any number here, which has the nth term here. So the first term is second term, third term, fourth term, and the last term is represented by nth term, that is Tn. And here we have A1, A2, A3, A4, it goes on, and the last term is nth term. So this is the end of the terms here. We will start with the number and end with Tn or An. So we have different types of sequences here. The first one is the finite sequence, and the second one is infinite sequence. Let us see what you mean by finite sequence, and let us see what you mean by infinite sequences also. So the definition for finite sequence is, write down, first one is finite sequence. What do you mean by finite sequence? Finite sequence, a sequence containing finite number of terms is called finite sequence. So any sequence which has finite number of terms. Finite number of terms means which are countable, which you can count sometimes, which have an R, in common words we can say which has an N, somewhere it ends there. So those terms are called, those sequences are called finite sequences. Here he has given the example, same thing you can write down the examples here. Here you can have 2, 4, 6, 8, 10, 12. So here you can count the number of terms in the sequences. So this is called finite sequences, where we can able to finite numbers means where we can count or which has an end of the sequence. These type of numbers are called finite sequences. And we have another also, the general formula. The general formula of finite sequence is finite sequence. What is the general formula of sequences here? Because the general formula of finite sequence is given as, I told you already, I can write with T1 or T2 or T3 up to Tn. So n is the last term, so which is a countable or which has the ending. Or you can go with A1, A2, A3 up to the nth term. This is the general form of finite sequences, and a sequence containing a finite number of terms is called finite sequences. Example is given here. And the general formula of finite sequences is T1, T2, T3 up to Tn, or it may be A1, A2, A3 up to An. That is nth term, which is countable. And we have another one which is called infinite sequences. Instead of finite, we have infinite number of terms is called infinite sequences. Let us see what are these infinite sequences are. Example is given there, 2, 4, 6, 8, 10. You can take the same example, but the thing is, they will not have any end. It goes on. So we cannot say where they will end. Where? In infinite sequences. In finite sequences, we can say where they will end and which is the last number, because we know that the last number is the nth number there. And in infinite sequences, there will be no end. It goes on continuing. And the general formula of infinite sequences is, what will be the general formula of infinite sequences? So there will be no end for these two. Same thing will be there, but the thing is, will not have any end for infinite sequences. So they will go on. We don't know where they will end and where they will stop also. So these type of two sequences, one is finite sequences and another one is infinite sequences. So we have finite sequence, infinite sequences, and also we have the general formula for both, for finite sequences and infinite sequences. So these are the examples for finite sequences as infinite sequences. So there is some example here. Let us see what are those examples here. If you solve one or two examples, you will come to know how we will find a sequence, how we will find the nth term of the sequence, or the number of sequences which are present, or the number of terms which are present in the sequences here. So first, what is telling is, so that it will be easy for you to understand, if I give one or two examples. Find first three terms find first three terms of the sequences whose nth term is whose nth term is 2n plus 3. So he has given one example. What he is saying is asking to find first three terms of the sequence. We know the sequence, orderly arrangement of numbers in certain rule. If they follow certain rule, then we call it as a sequence. But what is the question here? Find first three terms of the sequence. What is the first three terms of the sequence whose nth term is given 2n plus 3? Nth term in the sense the last term. The last term what he has given? he has given 2n plus 3. If nth term is 2n plus 3, then what will be the first three terms of the sequence? It is very simple. So what is given? Nth term is given. I told you can write both as an as well as tn. So I am going with tn. Why? Because it will be easy for you to remember also. So tn is nth term equals how much he has given? 2n plus 3 as mentioned. So the nth term he has mentioned 2n plus 3. If nth term is 2n plus 3, what will be the first three terms? So let us see what will be the first three terms. If we take first term, of the sequence, then here the value of n will be 1. Why? Because we are taking first term. He is asking first three terms, so n will be 1. If n equals to 1, then this equation changes to T1. Why T1? Because it is the first term, I am taking T1. Or else I told you already, you can take A1 also, no problem. But T is very easy, so it will make you remember T represents term here. So T1 equals to 2n plus 3. But n equals to 1 he has given. T1 equals to T. What is the value of n here? N equals to 1 plus 3. So T1 equals to 2 plus 3. So T1 equals to 5. So what is the first term is? The first term is 5. The first term of the sequence is 5. Now find the second term. Same thing. Instead of 1, take n equals to 2. If you take n equals to 2, what you will get? You will get T2 equals to 2n plus 3. So T2 equals to 2 of. In the value of n we have 2 plus 3. So T2 equals to 2 into 2 is 4. 4 plus 3. So T2 equals to 7. So the second term is 7. What is the first term? First term is 5. Second term is 7. T2. Now take third term, because the question is he is asking three terms, n equals to 3. So we have T3 equals to 2n plus 3. T3 equals to 2 of 3, because the value of n is 3 here. 2 3 plus 3. So 2 3 equals to 2 3 is 6, you will get 6 plus 3. So 2 3 equals to 6 plus 3 is 9. So 9 will be the third term. So 9 is the third term. So you can see here the first term is 5, the second term is 7, and the third term is 9. So these are the three terms of the sequence where he has given the nth term, the last term. Nth term in the sense the last term. He has given the nth term and he is asking us to find the first three terms. So these are the first term and second term and the third term. I hope you understood this one. So after this we'll go for the second question. Let us see what is second question there. Okay, let us go for second question. The second question is same thing here. Find the first four terms of the sequence. Second one. See, these are the problems which will make you understand what you mean by terms, sequences and everything. Which is the nth term, which is the first term, which is the second term. How to find the first term, second term and third term or fourth term, whatever it is. So yes, you can find the first four terms. Find the first four terms of the sequence. Whose nth term is asking who is the nth term is n square by n plus 1. See here. First four terms you have to find. The sequence whose nth term he has given. Nth term is here n square plus 1. So if the nth term is n square plus 1, then what will be the first 4 terms of the sequence? Same rules you have to follow what we did in the first problem. So I told you either you can take T1 or A1 or Tn or An. You can take any one. So I'm taking here. He has given Tn. Tn equals to what? N square by n plus 1 he has given. So his first 4 terms is the question. So first 4 terms means n will become 1. If n becomes 1, then the equation changes to T1. Why? Because instead of n you are taking 1 here. So T1 equals to n square in the sense 1 square by 1 plus 1. This equals to 1 square is 1 and 1 plus 1 is 2. So the first term is 1 by 2. That is what is the second term here. Second term, n equals to 2. Same thing, Tn equals to n square by n plus 1. This equals to, what is the value of n here? 2 is given. 2 square by n value is 2. 2 plus 1. This equals to, what is 2 square? 2 square is 4. 2 plus 1 is 3. So that second term is 4 by 3. Now if we take one, can find third term, n equals to 3. The equation is T3 equals to 3 square by 3 plus 1. So T3 equals to 3 square is 9 and 3 plus 1 is 4. So T3 is 9 by 4. So this is 9 by 4. And is asking 4 terms. This is third term. Now if you take n equals to 4, then you will get T4 equals to 4 square by 4 plus 1. So this equals to 4 square is 16 and 4 plus 1 is 5. So the fourth term is 16 by 5. Therefore, the first 4 terms of the sequence where the sequence ends with n square by n plus 1 is 1 by 2, 4 by 3, 9 by 4 and 16 by 5. This will be the answer. Remember, these type of questions you will get for 2 marks. So give concentration. They look easily, but when solving it will be, try to do revision. Okay. We'll go for the next problem then. Find the 20th term of the sequence if Tn equals to 3n minus 10. So what is the question is? The question is find the 20th term of the sequence if Tn equals to 3n minus 10. See, in the first 2 problems, he used to ask what is the first term, what is second term and what is the third term. But here is not asking what is first term, what is second term and what is third term. Directly what he is asking here to find the 20th term of the sequence. See, whether it is 4th term, 5th term, 6th term, he is not asking. Directly he is asking which will be the 20th terms of the sequence if the nth term will be 3n minus 10. If the nth term is 3n minus 10, then what will be the 20th term? So here, what is given there? The nth term is given. So Tn equals to how much? 3n minus 10 is given. So 20th term is asking. So 20th term means n equals to 20 because we want the 20th term. So T20 equals to 3 into 20. Why? Because the value of n is 20 here minus 10. So T20 equals to 3 into 20 is 60 minus 10. So T20 equals to 50. So the 20th term of the sequence Tn equals to 3n minus 10 will be 50. So if you go on writing the terms, first term, second term, third term, fourth term, fifth term, sixth term, seventh term, whatever it is, at last you will go for the 20th term. When you come for the 20th term, the 20th term will be always 50. So this indicates the 20th term is 50 here. Okay, copy now. See, we are going different types of problems. So we are not solving the same type of problem, just the problems will be changed here. The next question is, if Tn equals to 5n plus 2, then find Tn plus 1. You see the question is very simple. He has given, if the nth term is 5n plus 2, then what will be the value of Tn plus 1? So take the thing which is given here. What is given? He has given the nth term. Nth term equals to 5n plus 2 he has given. So what is the value of n here? So here n becomes n plus 1. Because here the nth place is n plus 1. So n becomes here n plus 1. So this is T of n plus 1 equals to 5 of, I told you what is the value of n. The value of n is n plus 1 plus 2. 5 of n plus 1 plus 2. So this is T of n plus 1 equals to 5 into n will get 5n plus 5 into 1, 5 plus 2. 2 remains as it is. So T of n plus 1 equals to 5n plus. What is 5 plus 2? 5 plus 2 is 7. So the Tn plus 1 is always equals to 5n plus 7. This is the value of Tn plus 1 equals to 5n plus 7 when Tn equals to 5n plus 2, given that n term is Tn plus 1. Okay, copy this. Now, if Tn equals to n cube minus 1, find the value of n so that Tn equals to 26. See the question. What is given here? If Tn equals to n cube minus 1, then find the value of n. What do you have to find? What is the value of n so that Tn equals to 26. So what we know that the given thing, what is given here is Tn here is given. Tn equals to n cube minus 1. Got it? So what is the value of Tn here? The value of Tn is 26 equals to n cube minus 1, because n cube remains same here. So 26 minus 1 you bring to LHS plus 1 equals to n cube, or I will write in this way so that it will be easy for you to understand. N cube equals to 26 plus 1, or n cube equals to 27. 26 plus 1 is 27, or n equals to cube root of 27. So the cube root of 27 is n equals to 3. So the value of n is 3 when Tn equals to n cube minus 1, and he has given the nth term equals to 26. This is the thing what we have. So we did many, I think 4 to 5 problems here, different kinds of problems, so that it will be easy for you to understand what is the nth term, what do you mean by sequence, what do you mean by finite sequence, what do you mean by infinite sequence, and how to find the nth terms also. Once again I am telling you, here he has mentioned Tn, you can go with An also or A1 also, whatever you want you can take it. For my convenience I am taking Tn. I told you already because T represents the term, so it will be easy for you to follow. So Tn equals to n cube minus 1. So at last you will get the value of n is 3. So the value of n is 3 when Tn equals to n cube minus 1. Okay, copy. This is all about sequences, series, finite series and infinite series. So what is the nth term, how to find the nth term, or how to find the first 3 terms in the sequence, or how to find the middle term of the sequence, maybe 4th term, 5th term, 20th term, whatever it is all about sequence. Now we are entering into arithmetic progressions. So now we are going into arithmetic progressions. So arithmetic progressions in some sense, what do you exactly mean by arithmetic progression? So the definition for arithmetic progression is, write down, a sequence in which the consecutive terms either increase or decrease, by a fixed number is called arithmetic progression. See here. It is a simple definition. We are not going to exactly what is mathematical definition. In simple definition, if you want to know what you mean by arithmetic progression, it is a sequence. I told you what do you mean by sequence already, in which the consecutive terms either they may increase or decrease by a fixed number is called arithmetic progression. First thing you have to give concentration is on the word consecutive. I told you what is consecutive because this word you got in quadratic equation also. What is the consecutive number? If a is the first number, then what will the consecutive number of a? I think you know that a plus 1 or a plus 2 or a plus 3. So the consecutive numbers which are in serial wise, if a is the first number, a plus 1 will be the second number, a plus 2 will be the third number, a plus 3 will be the fourth number, whatever it is. A sequence, and that should be in consecutive terms, that should be in a formal term, consecutive term, which may increase or which may decrease by a fixed number. Increasing in the sense, for example, if I write 1, 2, 3, 4. See, they are increasing here. These are the consecutive numbers 1, 2, 3, 4. Increasing in the sense by a fixed number. What is the fixed number here? For 1 I am adding 1. So if I add 1, it becomes 2. For 2 again I am adding 1 here. So if I add 1 for 2, it becomes 3. Again I am adding 1 here. If I add 1, it becomes 4. So it goes on. So here increasing by a fixed number. Okay, and the fixed number is 1 here. We are adding 1 to each number in the sequences, or each term is added by 1. I told you already what you mean by term also. So each term is added by 1. So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. So it goes on like this only, which increases or it may decrease. It is left to. Here it is decreasing here. And same thing by a fixed number is called an arithmetic progression. Arithmetic progression, general definition. The general definition what you call. So a sequence in which the consecutive terms either increase or decrease by a fixed number is called arithmetic progressions. Or if you want to go and it is abbreviated. What do you mean by abbreviated? It is abbreviated as AP. Abbreviated AP in the sense, generally when we are writing arithmetic progressions, we won't go on writing arithmetic progression in words. So what we'll write abbreviated means it is in the short form. In the short form we will write it as AP. AP indicates what? Arithmetic progression. But one thing you remember, they both should be in capital letters. You should not write in small letters. The both should be in capital letters. So it is abbreviated as AP. And or you can write an arithmetic progression is a sequence in which each term is obtained by adding a fixed number to the preceding term this is important, except the first term. See here, we have two definitions here. One is an arithmetic progression is a sequence in which each term is obtained. Means if the first term is 1, the second term is obtained. How it is obtained? By adding a fixed number. I told you already. The fixed number may be any number. It may be 1, 2, 3, 4, whatever it is. It should be a fixed number. What? To the preceding number. The number should be added to the preceding number, but keep it that it should not be a first term. This will come to know why it is not in the first term. So take the definition here. An arithmetic progression is a sequence in which each term is obtained by adding a fixed number to the preceding term except the first term. So the preceding number generally what we are adding to it will be always constant. So the number which you are adding to the preceding number, whatever the number it may be 1, 2, 3, whatever the number it may be, what the number we are adding to the preceding number, that preceding number will always be a constant. So the number will be always constant, and that number is called, and that constant number, what is this constant number? This constant number is called common difference. What do you call this number? This number is called common difference, and it is abbreviated, what I told you here, and it is abbreviated as D. It should be small d. Here it is abbreviated as AP, which is in capital letters, arithmetic progression, whereas the constant number which you are adding to the consecutive number, that is called common difference, and that common difference is denoted by the letter called D, which is small d. It is not capital D, keep it in mind, it should be always a small d. So this is called common difference. Okay. And another thing, the common difference, I told you already, it may be a positive number or it may be a negative number. We are not bothered about that thing, but the main thing is it should be a constant number, and it is called common difference, and it is denoted by small d. Okay, copy it. Okay, now till now we saw what are the definitions of arithmetic progression, finite, infinite, everything we saw here. So what do you mean by common difference? What is constant? How the common difference will be? Everything will be there. Now we will see what is the general form of AP. So general form of an AP. So what will be the general form of AP? So for example, if you take the first term T1 equals to A. What I am taking? T1 equals to A I am taking here. You can observe here, there we have T1 equals to A and T2 equals to T1. What will get? Plus D. Why T1 equals to D? I told you what is T1? T1 is the first term. So A in the sense, A is the first term. Here T2 equals to what? T1 plus D. Why we are taking D here? I told you in a sequence, either you should add or you should subtract by a constant number. That constant number is called common difference. That's why what we are doing, we are adding T1 plus D here. See, if you observe carefully, what is T1 here? T1 is A. So this instead of T1, I can write A. This becomes A plus D. Get the point? T1 is A. T2 is T1 plus D. Why D? Again I told you it is a constant, that is common difference denoted by D. But I am taking here A. Why A here? Because T1 is A. First we are taken T1 is the first term. So A is what you mean by A? A is nothing but the first term. For the first term what we are adding? Common difference. For the first term if you add common difference you will get the second term. Now if you take T3. So how can I write T3? T3 can be written as T2 plus D. Okay, T2 plus D. Again, what is D? D is common difference. So what is T2 here? T2 is A plus D, and remaining is T2 is A plus D, and remaining is plus D. This becomes A plus D 2D. So T3 is T2 plus D, or A plus D, or A plus 2D. Or if I write T4, this I can write T3 plus D. This equals to, what is T3? T3 is A plus 2D. So A plus 2D plus D. D is here T3. Instead of T3, I am writing A plus 2D. Why? Because T3 equals to A plus 2D. So T3 plus D equals to A plus 2D. This can be written as A plus 2D plus D is 3D. And the same, it goes on continuation. If you want, you can write T5 also. T5 is T4 plus D. This equals to what? What is T4? A plus 3D plus, we have D here. This equals to A plus 3D is there. A as it is plus. What is 3D plus D? 3D plus D is 4D. So generally, if you want to write, so T1 equals to A, T2 equals to what we have? A plus D, T3 equals to A plus 2D, T4 equals to A plus 3D, and T5 equals to A plus 4D, and it goes a continuation. There is no end for this at all, and so on. So general formula in the sense, T2 means what here? 2 means second term. Second term can be written as A plus D. Third can be written as A plus 2D, where A is the first term and D is the common difference. So when you want to write the third term, you can write directly A plus 2D. If you want to write the fourth term, you can write A plus 3D. Or if you want to write the fifth term, you can write A plus 4D. This goes on continuation. So T1, T2 equals to A plus D, T3 equals to A plus 2D, T4 equals to A plus 3D, and T5 equals to A plus 4D. It goes on continuation. Let us see how it goes on continuation. Same thing here, you have, I told you already, finite progressions, finite sequence and infinite sequence. In the same way, we have finite sequence and also infinite sequence also. So how this pattern will work out? How the pattern will work out? Let us see in one form. I'll give the table, copy the table. After copying the table, you come to know what is the general form of NAP in simple words. Okay? Copy this one. Of an AP here. So I'll give a small table, copy the table, you'll get exact picture. We have number of squares, if you want to take one common, and this is number of sticks. First to take down the table, I will explain you what you mean by this one. Pattern, and we have expressed in terms of number of squares. Just a small table. I'll explain each table one by one. So first we'll go with squares, number of squares. How many number of first square is number 1. We have only one square. So this is square. So how many sticks we are using to make a square? For example, if you take a matchbox sticks, how many sticks will take generally? We'll take 4 sticks, no? So that's what we'll take. 4 sticks we are using. Same pattern will be 4 and expressed in terms of squares will be 4 only. Why? Because we are using only 4 sticks there. If you come to second one, so if you want second square, now tell me how many sticks are there here? First we have 4 and this is 1, 2, 3, 4. First we have 4 here and this is the fifth one, this is the sixth one and this is the seventh one. So totally how many sticks are there here? Totally 7 sticks are there. So these 7 sticks can be written in how? 7 can be written as in the form of 4 plus 3. Getting? The first one is first square. So the pattern will be same there. But in number of squares in the second square what we are doing? We are taking 2 squares here. For the 2 squares we are adding the sticks here. For 1 square how many sticks we are adding? We are adding 3 sticks here. So total number of sticks is 7 and the pattern is 4 plus 3 here, because 4 plus 3, 7 sticks here. So expressed in terms of things in the sense 4 plus 3, 2 minus 1. Why 4 plus 3, 2 minus 1? I can write 3 in the form of 2 minus 1. What is 2 minus 1? 2 minus 1 is 1 only. 1 into 3 is 3. 3 plus 4 is 7. Or totally 2 squares are there. In 2 squares we are taking 1 square outside, that is 2 minus 1. Totally 7 are there. If we take next one, third one. So how many squares we need here? We need 3 squares here. 1, 2, 3. Now in these 3 squares how many sticks are there? First one is 4, second one is 3, next one is 3. 4, 3, 3. 4 plus 3, 7. 7 plus 3, 10. Total number of sticks are how many now? 10. This can be written as 4 plus 3 plus 3, or this can be written as 4 plus 3. I can write it as 3 minus 1. 3 minus 1 is 2. 2 3 is 6. 6 plus 4 is 10. Same thing you are getting here. Observe here. 3 minus 1 is 2. 2 3 is 6. 6 plus 4 is 10. So 4 plus 4 plus 3 is 10. 10, 10, 10. Same thing you can go on writing like this. Now you can write fourth square. So first square, second square, third square, fourth square. So here we have 4 sticks here and we have 3, 3, 3 here. Total 4 squares are there here. So 4 plus 3, 7, 7 plus 3, 10. 10 plus 3 how much here? 13 we have. So this can be written as 4 plus 3 plus 3 plus 3. 3 plus 3 6, 6 plus 3 9, 9 plus 4 13. Pattern will be same, 4 plus 3, because we are going on increasing 3 sticks here. That is common thing is what we are doing. We are going on increasing 3 sticks. But what is the first square we have? We have only 4 sticks. That is common for 4 for everything. And 3 is common. Why? Because we are going on increasing 3 here. And this becomes, instead of 3 minus 1, we will get 4 minus 1. Now see here, 4 minus 1 is 3. 3 1 is 3 here. 4 minus 1 is 3. 3 into 3 is 9. 9 plus 4 is 13. In the same way, if you go on increasing, the last term will be nth term. This we can come on nth. But this will be what? What is 4 here? 4 is the first. Let us see, 4 plus 3 of, that I can write n minus 1. So observe here, n is there, 4 is there, 4 minus 1 we have written, 3 is there, 3 minus 1 we have written, 2 is there, 2 minus 1 we have written, and nth term is there. So that's why we are writing n minus 1. So what do you mean by this 4 plus 3 of n minus 1? What is 4 here? 4 is the first term. How many sticks we had here? 4 sticks we had. 4 is the first one. So 4 can be represented as the first term in the sequence. So what is the first term in the sequence? Generally we use the letter A plus. The first term is A because 4 is the first term here. Because common is 4 for 4, the fourth term is A plus. 3 is what? The common difference here. You can see, observe that. The common difference is always 3 here. 3, 3, 3, 3. It goes on increasing. Whatever you do here, you will get 3 here, 3 here, 3 here, 3 here. Instead of n plus 1, I will write n minus 1. Instead of 3, I will write here D. So, general form is A plus n minus 1D, where A is the first term, what it called as 4, and n minus 1 I am writing as it is. Instead of writing 3 here, I am writing D here. Multiplication we can write anywhere because it is convenient for that. So A plus n minus 1 D, or in general we can write Tn equals to A plus n minus 1 D. This is the general formula of the arithmetic progression, where Tn is the nth term, A is the first term, and D is the common difference. So the general form of AP is Tn equals to A plus n minus 1 D. I will tell you in detail, just to copy this one. Okay, children. So now we know how we got the general formula of AP. Now just take the definition. The general formula of AP with A as first term and D as common difference is, so generally I told you already what is the first term. First term will be A, second term is A plus D, third term is A plus 2D, A plus 3D. It goes on, at last you will get A plus n minus 1D. Getting the point? So the general formula of an AP with A as first term and D as common difference is A plus D, A plus 2D, A plus 3D, and A plus of n minus 1D. In short term, you can write AP is Tn equals to A plus n minus 1D. So this is how we got the formula. See children, I told you already this is not from our textbook also, because I am referring other textbooks and making it to feel it easy so that you can understand. If I write directly the general form AP is Tn equals to A plus N minus 1D, you will not come to know what are the terms of A, what is Tn, what is N and what is D also. Okay, this is how you will get the formula for general form of AP. So the general form of AP is Tn equals to A plus 1 N minus D. Okay, you find this one, you copy this one. I'll give you one example. What do you mean exactly by this one? Okay children, till now we have studied, I think what you studied, sequence we have studied, and you know what do you mean by sequences, and we studied finite sequences, infinite sequences, and we also went with some problems related to sequence. We have to find the nth term and we have to find the 20th term, everything we did it. And also we came to arithmetic progression. There also in arithmetic progression, what is the general form of arithmetic progression, and we delivered the general form of arithmetic progression also. So that formula you have to keep it in mind. How we got that formula is very important, because the terms which are using there in the formula are very important, because while solving the problem we will be using these terms, and again we will not go to tell you that what do you mean by D, what do you mean by A, what is mean by Tn. So you have to keep it in mind, work out with these things, and in the next class I will go with some worked examples of problems based on general formula of arithmetic progression, that is Tn equals to A plus N minus 1D. Then after solving some problems, we'll go directly to the exercise problems here, because if you solve 1 to 2, 3 problems, you'll come to know what do you mean exactly the meaning of this formula, why we are using this formula. That is the thing. And I told you already in the one class, I don't know whether you remember it or not, why we use this formula, why we use some formulas. I told you one small story also. I will end up the program today's class with this small story. One boy was there, was making hell of noise. I told you for one section, I think. For another section, I told you, I think you won't remember not. So he was very naughty boy in the class. So he was doing mischief in the maths class, especially in the maths class. So the teacher asked him, why you are doing so mischief in the class, why you are not sitting quiet? Then the student he stood up and asked the sir, sir, give me any work to do so that I will be busy with my work, so I will not make any voice. So you have to give me such type of work so that I must be busy with that work and I will keep quiet while doing that work. So what the teacher did is, he asked the student to add the numbers. I will give one small example, from 1 to 1000. Adding the numbers from 1 to 1000 in the sense 1 plus 2 plus 3 plus 4 plus 5 plus 6. You should go on adding up to where he much had, up to 1000 numbers he much had. But it is not exactly 1000, it is more than 1000. But for example, I am telling you. The teacher asked the student to count the numbers from 1 to 1000. He must add the numbers. First he must add what is 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15. 15 plus 6. Like this, he should go on adding the numbers up to where? Up to 1000 numbers he told. So what the teacher thought? So at least he will take time up to evening to count the numbers from 1 to 1000. After 10 to 15 seconds, give the example, the boy who was adding these numbers, he stood and told, sir, this is the numbers, what is the number what I got after adding all the numbers beginning from 1 to 1000. Just in 10 to 15 seconds. Can you imagine, if you go on adding 1 plus 2 plus 3 plus 4 plus 5 plus 6 up to 1000, how much time it may take for you generally? But that boy gave the answer in 10 to 15 seconds. It was nearly shocking for the teacher. Because the teacher knows the formula, then he started doing whether what the student has told is correct or not. So he took the book and he started adding the numbers with the formulas what he knows. For his surprise, what the answer was given by the student was exact the same what he got the answer. The teacher was shocked. Do you know what is the age of the student at that time? The age of the boy was nearly 12 to 14 years. 12 to 14 years. Age of the boy of 12 to 14 years who gave the numbers of adding the numbers from 1 to 1000 just in 15 seconds, how is it possible? So you can also do this. How? Because of arithmetic progression. If you're perfect with these formulas and everything, you can also do this, but the main thing is you should get practice at it. So these are very important. So practice well. See you in the next class. Thank you, children.